We're on lesson 1 of chapter 11, which is finding probabilities and odds. First, we're going to find a sample space. Then we're going to find theoretical and experimental probability. Then we're going to find the odds. First, let's look at what a sample space is. A sample space is all the possible outcomes of an event. So for example, if my event was rolling two six-sided dice, a green die and a red die, the sample space then would be all of these possible outcomes, which could be a 1 for a green and 1 for a red, a 3 for a green and 4 for a red, and so on and so on. In this sample space, there are a total of 6 rows and 6 columns, making that for 36 total outcomes in the sample space. So that's all that is. You have to just write out all the outcomes. So if you're going to solve a sample space problem, you flip a coin and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes using a tree diagram. Using a tree diagram is useful when you have two different things that you're doing. You do one at a time and you kind of branch off with all the different possible outcomes. When we flip a coin, it could either be heads or it could be tails. So let's say it was heads. After I roll a heads, I then could roll the number cube and get a 1. Or I could roll a number cube and get a 2. Or a 3, a 4, a 5, or a 6. On the other hand, if I flip and get a tails, I could still roll a 1, a 2, a 3, a 4, a 5, and a 6. So this is not the most perfect tree diagram since these branches don't all the way go back here, but this is the idea. Then if we count them up, I count a total of 12 outcomes. When it asks you to list the possible outcomes, you actually have to list them out. Sometimes you won't have to, and then there's a shortcut for that. And when you flip a coin, there's 2 different total outcomes. When you roll a number cube, there's 6. Well, you notice 2 times 6 is actually 12. Because you can see there's 6 outcomes 2 times. And that's why rolling 2 number cubes, there's 6 outcomes times 6 outcomes, gives you 36 total outcomes in the sample space. Next is probability. We're looking at theoretical probability and experimental probability. Probability is just the chances that something favorable is going to happen. So theoretical probability is found by looking for your favorable outcomes in the sample space. So let's say in this sample space I really wanted to roll a 4. So I'd put my favorable outcomes on the top over the total number of outcomes on the bottom. So here's a 4, a 1 and a 3, a 2 and a 2 is 4, and a 3 and a 1 is 4. That's a total of 3 outcomes. And the total number of outcomes we've determined already is 36. So it's a 3 out of 36 odds, which simplifies into 1 out of 12. Experimental probability is found by using previous results of an experiment or a situation to make a prediction. So we have your total number of times you were successful over the total number of trials. This is used in a situation such as calculating batting average in softball or baseball. If you get 6 hits in 12 at-bats, that'd be a probability of 6 over 12 that you would get a hit the next time, or 1 out of 2 chance, if you would simplify that. So let's solve these ones. First we need to determine if they are theoretical or experimental, then we can solve it. It says you and your friends designed t-shirts with silk screened emblems, and you are selling the t-shirts to raise money. The table below shows the number of t-shirts you have in each design. A student chooses a t-shirt at random. What is the probability that a student chooses a red t-shirt? So this actually looks like a sample space. This is what all the total possible outcomes that you have. You have 10 green and gold, you have 6 red and gold, 8 green and silver, and 6 red and silver. We're looking for the probability that the student chooses a red t-shirt. So a red t-shirt is our favorable outcome. I count a total of 12 red t-shirts. That goes on top. Then we have the total number of outcomes on the bottom. We have 18 plus 6 is 24, plus 6 is 30. So it would be 12 out of 30. It's always good to simplify when we can. These can both be divided by 6, leaving us with 2 out of 5, 2/5. And then if you want to show it as a percent, there would be a 40% chance that the red t-shirt would be picked. Let's do this one then. Each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results of spinning that spinner. For which color is the experimental probability of stopping on the color the same as the theoretical probability? First, maybe it'd be good if we thought about the theoretical probability. Since there are 4 total outcomes, that would go on the bottom in theoretical probability, and there's only 1 favorable outcome. So that would be our theoretical probability of landing on the color you want. So we're looking for a 1 out of 4 experimental probability. Let's look at the total number of trials. We said that it was spun 20 times. So which one of these results would match the 1 out of 4 probability? We're looking for something that is 1/4 of 20. Well, that would be 5 for red. 5 out of 20 simplifies into 1 out of 4. So for experimental probability, red would match the theoretical probability. Now we're looking at odds, which work a little bit different than probability. In probability, we took the favorable outcomes over the total number of outcomes. Odds in favor, for example, take the favorable outcomes compared to the unfavorable. Then odds against take the unfavorable outcomes compared to the favorable. Let's say I was playing a game and I would win 2 out of 3 games. That means that I would win 2 for every 1 that I would lose, 2 to 1 odds. It also could be written like this, 2 to 1. If I was writing this like odds against, I would say unfavorable outcome would be 1, my favorable outcome would be 2, and that could also be written as 1 to 2 odds that I would lose. So let's try that here. Using this spinner, find the odds against stopping on green. So this is actually odds against, where you have unfavorable over favorable. So we'd have 4 total outcomes here. 3 of them would be unfavorable to green. And then only 1 would be favorable to green. And that would leave us with a 3 to 1 odds. If we're finding the odds for stopping on blue or yellow, we're looking for favorable on top, unfavorable on the bottom. Blue or yellow would be 2. The other 2 would be 2 total against, making that a 1 to 1 ratio, which could also be written like this.